Okay, so we're gonna finish up 5-2 today. We've done properties of exponents. Now we're gonna do equations. So we have to get some little vocabulary. I gave you a vocab sheet. And, oh, and by the way, if you want to get updates, like I might remind you that there's a quiz or homework, what the homework is, I could, one more thing to do, but I could Twitter it out, and there's my Twitter name. It says totally for class. So no, I'm not gonna follow you because it's fine. But you can follow me, and I'll put up there when we have quizzes. So we have a full week of school next week, and then 2 days the week after. So that'll be nice. We've had really a wonderful November. I don't ever remember November with the weather this nice. Well, no, actually one year I played golf over Thanksgiving because it was still green. But we had cold weather. We haven't had any cold weather yet. Which is not good for any of us with allergies. Okay. This is on your handout somewhere. Where did I put my handouts? We need to know the vocabulary. I'm finding that that's one of the problems. Expression is the second one down, and then equation is the fourth one down. And we may hit some of those other words when we're at it. So we have expressions and we have equations, and we have those in English as well, okay? So we have expressions, and English would be a phrase. Just a phrase. And an equation is a sentence. So I'll do this. Okay, so an expression is a math phrase. I think I fixed it so it's not so big. And this is a math sentence. What's the difference between a phrase and a sentence? Think of English. We're in English class now. Pardon? Because it has something else. Maddie? Yeah, phrase is incomplete, but what does a sentence have? The equation has an equal sign, which in English we would call a verb. Am I not remembering my English? This has an equal sign. It has a verb, which means action. This does not. An expression, I could say my poor Yoda. Yoda had surgery yesterday. I put a video up on YouTube. He's like this. I thought he was going to fall off the couch, really, but he didn't. And he's doing just fine, but it was kind of cute last night. So I could talk about my poor Yoda, but I don't have any action there.
What'd you call it?
Yoda. Yoda would be a tag to look for. And my channel is Golden Bess. Yeah. And you'll see all sorts of math lessons there, plus some funny videos. So I couldn't resist that last night. You'll see Sassy the cat eating the cat who eats students' homework. I did. She was killed a few years ago. Yeah, I've had a lot of losses, but I have a new kitten now. So, I should bring a picture in and you can help me name her. She's black and white, and she has just a little thing on the end of her tail. Okay, so you can think about that. Okay, so you see the difference between expression and an equation. Expressions we simplify. Equations we solve. And see, listen to all the words. We solve those. Simplify and solve sound a lot alike. Sequences and series and partial sums. All of that sounds a lot alike. Okay, Alex? So that's the thing. So what does it mean? Let's look at simplify. And sometimes I care about simplifying it. Sometimes I don't. It depends on what the learning target is. And my learning target, I should have written that up there. I forgot to do that. Well, I did, sort of. And then I want to put them all on the board. And by the way, I put the assignments on that board and that board in case you can't see one or the other. The learning target is to solve. So we have to know what that means. Exponential and power equations. Okay, so that's what we're gonna do. We're gonna solve. So what does solve mean? Let me give you an example. Let's first start with simplify. Simplify just means to make it simpler. Make the expression, or it could be half of an equation, simpler. So if you have 3x plus 2x, we can simplify that, can't we? But the question is, Alex, why can I add the 3 and the 2? Because if we don't know why we can do that, we're going to have some problems with some of the math. We are going to use the distributive property, and we're going to undo what was distributed. In other words, we're going to factor this. That's a word I probably should have had on the sheet. Factor is to rewrite this as the product of two expressions. So what's the common factor here?
X.
Because I've done this in my other classes, but that's okay. And what's left? 3 plus 2. I can do that. That's why you can add the 3 and the 2, because if I factor out the x, I'm left with 3 plus 2. And I know what that is. That's just fine. So that's simplified, trying to make it simpler. Expanding a binomial, I don't know if that's any simpler, really. We would probably say the word expand if that's what we wanted. So here's an equation. The equation has a verb, has action, has an equals, or it could have an inequality, but we're going to do equations. Come on in. And I'm going to say x plus 3 equals 7. And I'm claiming that I solved this equation and I determined that x is equal to 3. Is that right?
No.
Why not?
Because X wrong.
Well, what do you mean it's wrong?
3 plus 3 is 6. Well, it could be.
What do you mean 3 plus 3? What did you do? You put this back in here, and what happened to my equations? I get 6 equal to 7.
Error.
Yeah, it's an error. So what is I'm looking for when I try to solve an equation? Why can't it be 3? Because it doesn't what? If I put it back in there, it doesn't make the sentence true. Solve, and if you know what solve means, you can solve anything. You get stuck on something, and you know what solve means, guess and check is wonderful. Now, it doesn't always work for, this is, easy things, that's easy. So, solve means to find the number or numbers that make the sentence true. Okay, I don't like to write the word number, so I write that. I put in parentheses numbers, because we could have 2 or more that make the sentence true. That's all solve means. So like when we did x squared equals 9, you told me that x was 3, but I want to find all the numbers that make that sentence true. What other number makes it true? Guess and check. 0 squared is not 9. 3 squared is 9. What else? There's one more. Negative 3. So could I solve this with guess and check? If I know what solve means, I need to find them all. One other thing, and I know you don't think this way, is this equation and this equation, well actually let's solve this correctly. Now solve means just find the number makes sentence true. What makes this one true? 4. Whoops, I hate that when I touch the screen. Okay, so if I put 4 in there, it makes the sentence true. This sentence and this sentence are not the same sentence, but they have the same possibilities, the same candidates to make them true. They don't always make them true. So you really always need to check by putting the 4 back in there. You could put 2 plus 2, that makes it true. I could put 2 plus 2 there. These are candidates that make the sentence true, but not everything will work necessarily. In this case it does because it's a nice linear equation. Okay, so when we're looking for solving equations, we're finding numbers that make the sentence true. I'm going to hit on that over and over again because that's so important. One topic that's always difficult for students is inequalities. If I have x greater than 3, if I translate that into English, I want to find all numbers larger than 3. Now, is that hard? What number, give me one number that's bigger than 3. 9. More. 12.
3.1.
3.1, which you're really close to, because what's my favorite number? Because we have pi on pi day, right?
3.1.
Pi. Okay, can I list them all? No. So what do? We draw a picture. Because I can't list them all, because I want to find all the numbers bigger than 3. So I would draw a number line like this, and I gotta get back to a pen. And here's 3, here's 2, here's 4. Now, everything to the right will make it true. And I'm going to go up to 3, and I always make big dots so you can see them, but they're really not big. You can get as close to 3 as you want. You can do 3.000001. I'm still not at 3. So we put an open circle here. Do you remember that? Put an open circle there. And that's a picture. That's what the lines on those graphs are. They are pictures of all the numbers that make that particular sentence true. Okay, so that's what solve means. That's an important thing. So we're going to solve some things. And before we do that, I want to add one more page because I forgot about it. We have power functions. Or let's call them power functions. And this is also hard because they're both involving exponents, exponential functions. Keep it simple, Mohammed. A power function is like y equals x squared or y equals x cubed. Notice that the base, I don't know if I stressed that in here, this is the base. The base is a variable. But an exponential function, and I'm going to use the same letters and numbers, looks like this, and they look a lot alike. X squared versus 2 to the x. No, you probably have to have notes, or, because I do put this online, if you go to Schoology, you can print it out. You can save it to your computer, whatever. Sometimes I forget, you might have to remind me. I don't mean to forget. So what's my base here? 2. So we're going to do a bunch of problems. That's base 2, and the exponent is the variable. Now just take a look at those. They look a lot alike, don't they? Do they look alike? Don't they? X squared 2 to the x?
Yep.
If you read it fast, can you get it wrong? Yes. An exponential function is the variable, is the exponent. Here, the base is the variable. These are nice functions. And we can study these whole families. We've done a little bit of that. We did the families. And this, we also looked at exponential functions. Okay. Now we're going to do these problems without a calculator if we can. Now these are equations. This is an exponential equation. So if I have 8x equals to 4, I want to find the numbers that make that true. I could do guess and check, but that might take me a while. Which I think was one of the problems where you could just do a guess and check. Okay, so I'm going to write out this in its prime factorization. Do you notice anything special about 8 and 4? Isn't 8 a multiple of 4? Yeah. So So let's go ahead and break this down to the base, because this really is base 2. So 8 is what? 2 what? Third, right? And that's to the x power equals 4. What's 4 is base 2? 2 to the second power. As long as these bases are the same, then the exponents will be the same. It's one of the properties. I don't even state it, I just do it. So what do I do with this? How do I simplify the left side? What do you do with these exponents? Remember? X to the m to the n. Do you remember what you do with those? Multiply them. See, it's the power of a power, and the operation I consider lower than that would be multiplication. Okay, so this is 2 to the what? 3x equals 2 to the second power. Then what do you think is true about the exponents? That exponent and that exponent. They're equal. If these are not the same base, I can't do that. But they are. So it's kind of nice. So I'm going to equate the exponents. 3x equals 2, and we divide by 3. And so x equals 2/3. Remember, we're trying to find numbers that make the sentence true. Now that's a fractional exponent. We're going to do those tomorrow. So right now you just say x to the 2/3. We'll worry about what that means tomorrow. It's just unfortunate that it's that way, but it is. How about b? 27 to the x equals 1/81. I'm never going to be able to guess that, I don't think. But there's something that 27 and 81 have in common. What? They're all powers. 81 is what? What's the base? Well, let's do 27. What's the base? Doesn't matter. Okay, so let's do prime factorization. What's 27? 9 times 3. Can we keep going? Yeah. And when I teach this, my 7th graders just hate to continue writing that down, but you need to write it down. What's the base? 3. So this is 3 cubed to the x. I can make lots of practice problems. There's not much in the book. And then this is 1 over. Now we just did 81 yesterday. Anybody remember what that was? It was 3 to the what power? 4th. And you're saying, I still can't make those the same because this is in the numerator, that's in the denominator. Can I simplify the left side? That's 3 to the what? 3x. All you do is, now if you have your properties, hopefully you know those properties. And this is what? I don't like that 3 in the denominator. I don't have the same base. Can I put it in the numerator? And if I do, what happens to the exponent? Negative. Is that okay? You gotta stop me if it's not okay. Usually I don't like negative exponents. Now I do, because now the bases are the same. I've got a base here of 3 and a base here of 3. Do I have another color? So these have to be equal, and that gives me an equation that I know how to solve. And you do too. 3x equals negative 4. Yes, exponents can be negative. Then what do I do to solve this? I could guess, or I could divide by 3. This is the process of solving. Solve means to find the number that makes the sentence true. And we're going to get fractional exponents. Just leave them. We'll talk about what they mean tomorrow, because that is section 5.3. That's my other one here. And sometimes I can't do anything. I'll have to use a calculator, but I don't think so. 49 ninths to the x. Is that to the x? Equals 3/7 to the 3/2. Try it. think of bases. These are exponential equations. Think of bases. Are these connected, the 49/9 and the 3/7? Do you see the connection? Fletcher? What's 49? Can you break it down to primes? What's 49? It's 7 to the what? Second power. And what's 9? 3 to the second power. That's to the x. Well, now it's looking a little bit better. Should I fix that 7 there? Yeah, I'll write it so you can read it. So this was 7 squared. Now, I didn't go over this property, but guess what? Those exponents distribute. Or I can pull it out. I think how I want to do this. This is 7/3 squared. That's what this is. And then I have it raised to the x power. I don't want to do any blackboard magic or smartboard magic. I don't want to do that. You see what I did? This 2 can distribute to the 7 and the 3. Are there questions on that? So if I have a over b to the x power, that's equal to a to the x over b to the x. What we have to do is learn to go backwards and forwards on these. Okay, Mohammed? I know it's not particularly exciting. Actually, I like doing these. And Ms. Rapson said this was probably one of the hardest units. So you need to ask questions and you need to come in right away for extra help if you're struggling. But I think we're okay right now.
I had a question on the first one, but we can go back to it after we do
Oh, okay. Let's finish this one. What do I want to do with this one? I don't want 3/7. What do I want? I want 7/3, don't I? And if I flip that, what happens to my exponent? Negative. Now they're the same. This is a positive too. It's just a little piece of ink. Because I pulled the 2 out here, so it's 7/3 on this side. Then I flipped that. I did the reciprocal. Because I want these bases to be the same. This has to be the same as this. It's a little dark. And if the bases are the same, then what has to be true about my exponents? They have to be equal. See, it's a good thing this takes me a little bit of time. So 2 times x has to equal -3/2. That's a nice linear equation. Now, be careful. Question?
So why is it 2x and not 2 to the x power?
Because if I have a to the x to the y power, then we multiply those, x, y, and I did skip that step. And you don't have to write that step, by the way. If you see it, and so I can see by looking around that some people see it, other people are not quite seeing it. We got more problems to do. Now, be careful with this one. What am I going to do? Divide by what? What am I going to divide by? The answer is not -3. I'm going to divide by what? 2. Where does the 2 go over here? Goes in the denominator. So what's the answer? -3/4. That's what I love about algebra. The numbers are easy, right? I don't have to know arithmetic. You guys have calculators. I didn't have that. So I hated arithmetic. I had to do it all. Okay? And I could check it by putting it back in and seeing if it works. So, and you actually could do it for excellence put on your calculator. Now, Maddie, you had a question back on
I had a question on that still.
this one?
The first one. So the one.
The very first one.
Yep. So you did 3x equals. Oh no, I know why you did that now. Okay.
That's good. That's good. That's why you gotta ask me questions, because I don't know.
Okay.
Okay, Dajanay. Wake up. You know, one way to say wake is to take notes. Although I have to admit I have fallen asleep standing up teaching at the board. So I get it. Don't know how that's possible, but okay, so let's try some more problems. And this is the general form of a power function. Exponential is a times, should we call it r? Because it is our common ratio. R to the n. No. To the x. Hang on, I'll fix that. Does that look familiar? That's our recursive geometric series. That's what an exponential function is. It is geometric. Okay, look at the difference here. The variable is the base here. R is a constant. That is my common ratio. The variable is in the exponent. So maybe I'll put that on a Schoology quiz. Just to make sure that we got that, because they look so much alike. But how you solve them are very, very different. Solving this, I'm going to need, if I have something nice, like if I have y equals 2 to the x, and I tell you that y is 8, you can guess and check that. What is x? 3. Okay? Focus. This is not so easy, so that's why I didn't go on yesterday. So x equals 3, plus I wanted to go over your homework. But what if I tell you 10 equals 2 to the x? Then you're going to have to take your calculator and put in numbers bigger than 3, 3.1, 3.2, and see if you can get 10. This is a preview for how we're going to undo this exponential equation. And Napier came up with a method, and he called them logarithms. So, and they're not easy because it's the first time you've done it. Okay, now this is one where, how do I solve that? Is that an exponential function, A? Or is that a power? It's a power, isn't it? Okay, so now how do we solve for x? What's the opposite of raising something? What if I have x squared? What's the opposite of x squared? X squared is square root. What's the opposite of the fourth power? What root? Fourth root. That makes sense. What other number would make sense there? So I'm going to take this to the fourth root, and I'm going to take this to the fourth root.
How do you do that?
On your calculator? Yeah, let's do that. By the way, this is an even power, so this is not just x, it's the absolute value of x. Remember, we want to find all the numbers that make the sentence true. So x is going to be the positive fourth root of 3,000. And I'm going to get my calculator out. If anybody wants to borrow mine, they don't have one, you may. Or negative fourth root of 3,000. Why do I get the negative? What if I take this negative to the fourth power? Will it become positive? Yes. The odd ones, you don't have to do the absolute value. But the even ones, you do. And I know it seems picky, but it's really important. So how do we do that on our calculator? Because you're going to be doing calculators. So clear. So I just want the fourth root. Now, okay. Technical difficulties. Okay. Maybe you just didn't like the fact that I moved it. So now I want the fourth root. Now if I go under math, oh, I do have that. It's fifth. It's number 5. So if you don't have the shortcut keys, you have to go down here to 5. And then you're going to type in the 4. And then you're going to type in the 3,000. And press enter. That's one way. Could you guess and check? Yeah. Why not? Take you a while. There's nothing wrong with guess and check, because guess and check tells me that you know what it means to solve. I'm trying to find a number that makes that true. Now, can I do it a different way? I'm going to do alpha, and it's window, I think. There's the root there. If you have the newer operating system and the shortcut keys. I don't know that it's any shorter. And And we put the 4 in there, and we put the 3,000. No matter how I do it, it's the same. Whoops, there it is. Okay, now all of our rules for solving equations are a little bit different. Well, they're not really different, but I like to think about isolating the variable. I have 6 times x to the 2.5. Go ahead and graph that on your calculator. You can't believe that the exponent could be a fraction, right? Sure, why not? No problems with it. Only problems we have are dividing by 0 and square rooting negative numbers. The only problems we have until we hit logarithms. Then we'll find some other problems. So, forget the 2.5. If you were to solve that, what would you do? I don't care about the 2.5 yet. You would what? Divide by 6. Anybody know how many times 6 goes into 90? I believe it goes evenly. All right. Yep, 15. How did I do that? Some of you maybe thought about it, but 90 and 6 is 3 times 2. So I took half of 90, which is 45, and then I took a third of 45, which is 15. But somebody else said 15. They beat me to it. So x to the 2.5 equals 15. Maybe we should change this to a fraction. That's a decimal. I don't like decimals. I know you love decimals. What is 2.5 as a fraction? What's 0.5 mean? Half. So it's 2.5. Can I write that as a fraction? Remember how to make improper fractions? And why does it work? I'm not going to worry about why it works, but it's 2 plus a half. But how you do it is 2 times 2 plus 1. Remember that? That's 5 halves. Then it's easier. Equals 15. How are we going to solve that? What's the opposite of 5 halves? Raising the 5 halves. I want that exponent to be 1. So I'm going to raise it to what? Anybody got a guess? Don't be afraid. What? 2 over 5. I heard that. Oh, I just get too close to the screen. How do we put that on our calculator? There's a couple ways we can do that. And this is kind of a preview into what we're doing tomorrow. We're going to do something with those exponents or fractions. So I'm going to type in 15. And I'm going to raise it, because I use the little caret, to the 2/5 power. Now I can change that to a decimal if I'd like. Or I'm just going to leave it as a fraction. Because I don't want to get it wrong. I know it's hard to see. Can you see that little 2/5 there? You can see it there maybe. Enter. I do all this on slide rule. I had my slide rule. I don't know what I did with it. Trust me, this is wonderful. Not even calculated. Just have to know how to use it, that's all. So think about it when we solve an equation, we want to isolate the x. The problem is if it's an exponent. Oh, that's your homework. Okay, questions on this? If you have the same basis. I don't want to use a calculator unless I have to. So this is the homework. These are no calculators except maybe to factor 243. So this is no calculator. Because you're going to have tests on this. And this is with a calculator. Let me give you a hint on F. F looks terrible. And I looked at that and I go, oh my goodness. I don't know why we're doing fractional exponents. We haven't even talked about it. Does anybody know what x to the 1/2 is? It's the square root. X to the 1/2 is equal to the square root of x. X to the 1/3. Anybody got a guess? Cube root of x. Okay? So I go back and forth between fractions and these roots, these radicals. But you know, that one looks hard. So why don't we make a little substitution and make it an easier problem? Why don't we let x to the 1/2, let's call it something different. What do you want to call it? A or Y or what do you call it? Call it star if you want. I can't call it X. X is used. I want to call it Y. Then this is negative 3 times what? This is Y, isn't it? Plus, and this is Y also. So it's 4Y equals 1. Can you solve that one? I'll just do the problem here. Can you solve that one? Yeah. Why can you add the 4 and the negative 3? Because you factor the Y out. Same thing here. I could factor that out if I didn't want to change it so it looked a little more pleasing to me. Does that look better than the original? Looks better to me. And we will be doing a lot of that, of changing an equation. I still have to deal with this, but changing the equation so it looks easier. So what is this going to give me? How many Y's? 4 negative 3. 1Y equals 1. So Y equals 1, but that's not what I'm looking for. What am I looking for? I'm looking for X. Come on. So I know that X to the 1/2 is equal to my Y, which is equal to 1. So I don't like that X to the 1/2. The square root of X is equal to 1. What number fits in there? I don't have to solve that, do I? Just because the process, what number can you put in there, make it true? See, I'm trying to get you to start thinking a little differently. 1. How would you solve it? What process would I do? I would undo the square rooting, which is squaring. No, Y does that. And so X equals 1. Does negative 1 work? Because I know you're probably thinking, oh, why can't we put in negative 1? Does negative 1 work? What's the square root of negative 1? Can't square root negatives. And back in the day, the mathematicians didn't know what to do with it, so they called them imaginary numbers. They're not imaginary numbers. They're very real. And all your calculators, all your phones work, all your electronics work with imaginary numbers. They'll be exponential functions with imaginary numbers. This is what we're going to call I. Don't think we do that this year. Unless you want to in the fourth quarter. This fourth quarter is up to me.
My calculator actually won't solve negative exponents or stuff like that. It just says there's an error, non-real answer, and then it won't give me.
So what did you do?
I don't actually remember, but like if I try to use imaginary numbers, my calculator will be like, nope.
Oh, you have to change your mode to imaginaries. Did you know you could do that?
No, it didn't.
Let's go back here. Is it mode or is it? I think it's second format. Let's look. Second format. And you can change all these things. You can change the colors of your grid. You can, and all these other things. Oh, detect asymptotes. That's nice. I wonder what it does if I don't do that. That's not the one mode though. Okay, see right here? Then I can write on it. A plus BI. That's the imaginaries. And then you can operate with imaginary numbers.
What number do you get to go there?
This is mode. Thank you for asking that. So should we try that? I'm done with my rest is just homework, so if you want to do homework. It is on. I think the blank page is up there, so you don't need your book. You just need Schoology. And so let's go ahead and turn this to the imaginaries, and let's try the square root of negative 1. Now, I haven't done this for a while, so I hope it works. Okay, second quick. Compare square root. See, I got I. Calculators are amazing. They are handheld computers. You need to get really good at it because if you're going to go into engineering, if you're thinking about that, or any science, you have to know you have to be able to use computers. So if you can use a calculator like this, you can use a computer. Because it's all going to be computer work. Okay, so what other ones here? Other ones I think should be okay. We always isolate our x. I want this guy all by itself, so I'm going to subtract 6 from both sides. These are calculator problems. It says, solve each equation if answers are not exact, approximate to 2 decimal places. So this is x to the 1/2. Would you prefer to see it written as a radical? Is that easier to understand? Yeah, so change it to what you works. So that's 3, and these, I need to help you with any of these. Do they look hard? E? No, D. Oh, you want to do E? Okay, so you want number 2. E. 3, is that x to the negative 2? I think it is. Equals 2x to the 4th. Well, first off, I don't like that negative exponent. So let's get rid of it. So what is this without a negative exponent? 3 over x squared equals 2x to the 4th. Math is so nice, it tells you what to do. Anybody know what that's called when 2 fractions are equal? That's with a P. Proportion. Okay? So proportions, you remember cross multiplying? You do it all the time in science. It tells me, it's begging me, I don't know what to do, so why don't I cross multiply? The product of the means equals the product of the extremes. So I get 2x to the 4th times x squared equals 3. So that's 2x to the what? 6. You forget, write out what it means. We want to isolate the x to the 6, so we'll divide by 2. Ooh, this looks like a calculator problem. I don't care, you can give me an exact answer. X to the 6th equals 3/2. What's the opposite of taking the 6th power? What root? The 6th. Sorry. So I'm going to take the 6th root of that, and you should be able to do that on your calculator. You want to do that, Fletcher? I'm sleeping over that. I got to learn some more names. And that's it. And let's see. This one, yeah, I assigned 3 through 7. This is just reviewing some exponents. The solution book is online. Please check your answers. If you're not getting them right, then you come in and say, hey, I did these problems, but they're not right. That's fine. We learn by making mistakes. And then you come in, and there's a little mini investigation I want you to do. And I do have 13 up here. And 13 is solving some equations. Give it a try, but we can talk about it tomorrow. I don't like C. This one's okay. This one's okay, but you have to use absolute value. Okay, you guys know what you're working on. Not time to go. Here's all your properties. Okay, now I gotta figure out how to do this.